Hello, my name is Karen Kate Manalo. I am a junior at WPI and I'm double majoring in chemical engineering and environmental engineering. And today we're going to be talking about wastewater treatment. During the 20th century, treatment processes were developed in order to remove solids, contaminants, and pathogens from wastewater. Biological treatment processes are some of the most effective ways of reducing matter derived from living organisms in wastewater. One of these processes is called the activated sludge process. The activated sludge process uses highly concentrated microorganisms, mostly bacteria, to degrade organic matter from wastewater. Wastewater treatment plants take influent water containing organic material from humans and animals and use the activated sludge process to treat it. The result is a high-quality effluent. The process was discovered around 1913, and the first full-scale activated sludge plant in the US was built for the city of Worcester, Massachusetts in 1916. Due to their efficiency in removing organic matter, activated sludge technology rapidly came into widespread use among wastewater treatment plants that treat large volumes of wastewater flows from densely populated areas. The main reaction that drives the activated sludge process is the decomposition of organic matter. Decomposition happens when microorganisms, such as bacteria, break down dead plants and animals to obtain energy. Bacteria can use available organic material to grow, reproduce, and convert them to end products. Bacteria are able to metabolize quicker in the presence of oxygen and heat. In order to obtain the desired level of performance in an activated sludge system, a proper balance must be maintained between the amount of food and the amount of organisms. All activated sludge systems contain two main components. The first is an aeration tank that carries out the biological treatment process, and the second is a clarifier tank that settles sludge and separates the treated water. Aeration tanks must be large in order to treat large volumes of wastewater, and they also require large areas of land needed for their operation. Other essential equipment include pumps, flow measurement devices, and mixers and blowers that provide aeration. An activated sludge system requires careful operation and observation and a lot of maintenance. Operators must be experts in biological treatment processes who are capable to supervise and monitor them. They're responsible for checking and adjusting various process control parameters, watching out for mechanical failures, and preventing system upsets. They also have to make engineering calculations that help characterize the sludge. In addition, considerable volumes of waste activated sludge need to be disposed of frequently. So, why is wastewater treatment important? Water is essential for communities to function and thrive. Each and every single person is entitled to the right to equal and non-discriminatory access to sufficient, safe, acceptable, physically accessible, and affordable water. Wastewater treatment has two main purposes. The first is to restore the water supply. Treated water is reused or returned to the water cycle. Wastewater is a valuable resource now, especially with recurring droughts and water scarcity in areas around the world. The second is to protect the health of ecosystems. Unfortunately, chemicals and pathogens in untreated wastewater can harm the health of humans and animals and contaminate crops and drinking water sources. So recall what you learned about activated sludge. Based on what you learned, activated sludge can be a resource recovery solution for water. It's significant because clean water is becoming scarce and over 2 billion people still lack adequate sanitation. Reaction engineers can use these concepts to develop new technologies that remove organic contaminants from the environment. However, there are still ongoing problems in the water treatment industry. The first is failing infrastructure and the rising cost of water. Aging pipes that were installed at the beginning of the 20th century will take 200 years before they're fully replaced. And failures in water infrastructure lead to very significant issues. This has caused water prices to skyrocket in recent decades. In addition, climate change effects will result in more severe storms in the East and Midwest and drought in the South and West, placing more strain on water systems. Ultimately, in the future, more households will be unable to afford their water bills. The second problem is disproportionate detrimental impacts among communities of color. So when water systems were constructed throughout the US in the 20th century, Black neighborhoods were delayed in receiving services. Research by the NAACP confirmed a connection between racial residential segregation and Black access to water systems. Black communities, Latinx residents along the US-Mexico border, and American Indian and Alaskan Native communities are more likely to lack access to basic water and sewer infrastructure. Numerous studies have concluded that there has been very little effective implementation of environmental justice policies. The third problem is that there's a need for more women in the workforce. A good example of a woman engineer is Ellen Swallow Richards, who was the most prominent female American chemist of the 19th century, who made important contributions to sewage treatment research, and she also encouraged women to enter the sciences. In 2018, women made up only 5.8% of water and wastewater operations. This percentage is extremely low, and I think that the industry can benefit from recruiting more women with interests in protecting public health and sustaining the environment. And companies can benefit from workforce diversity because it leads to new ideas, innovation, and progress. So in summary, why should we care about wastewater treatment? We should care about it because it restores the water supply and protects health. The second reason is challenges that endanger water accessibility and affordability call for major technology advancements. And lastly, environmental justice and equity issues surrounding gender and race still need to be addressed. And here's a wonderful quote by Ellen Swallow Richards that reads, "The environment that people live in is the environment that they respond to and perpetuate. If the environment is good, so be it. But if it is poor, so is the quality of life within it." So that concludes my presentation. I hope you enjoyed it. And if you're a woman, and especially if you're a woman of color, I do encourage you to go into STEM and go into this industry. Thanks.